Hello student, today I will teach you about pseudochirality. तो फर्स्ट ऑफ ऑल व्हाट मीन बाय द pseudochiral कार्बन. तो इसके पहले ये समझने के पहले आपको मेरा प्रीवियस वीडियो देखना पड़ेगा जिसमें मैंने एक्सप्लेन किया है हाउ टू फाइंड टोटल नंबर ऑफ स्टीरियोआइसोमर, ऑप्टिकली एक्टिव स्टीरियोआइसोमर एंड ऑप्टिकली इनएक्टिव स्टीरियोआइसोमर for symmetrically substituted molecule and asymmetrically substituted molecule. आपको रिक्वेस्ट है कि पहले वो वीडियो देखो उसके बाद ये वीडियो देखो. ओके, सो फर्स्ट ऑफ ऑल स्यूडोकिराल कार्बन और स्यूडोकाइरोजेनिक कार्बन और स्यूडोकाइरोट्रोपिक कार्बन all are synonyms of each other. So first of all I am giving one example. In previous lecture I have explained you. So this is the symmetrically substituted molecule, right? Because terminal functional group are same and there will be even number of chiral center. Now 1 2 3, right? Okay, now think about carbon number 2, carbon number 3 and carbon number 4. So now carbon number 3 2 we can say it is the chiral because one is hydrogen, one is OH group, one is COH group and one is this all CHOH group. So second number carbon is chiral center. So same to same for fourth number carbon is also chiral. Now for 3 number carbon, third carbon we can say one is hydrogen, one is OH group. Now all neighboring functional group are same, so we can say they are constitutionally they are same. Constitutionally we can say they are same, but if this both functional group are configurationally different, configurationally matlab one is R or one is S, then we can say that this third number carbon is chiral carbon, right? Okay, so this both we can say this both functional group are constitutionally same. But suppose one is R and one is S, if then we can say they are configurationally different, that is one is R and one is S, then center carbon, carbon number 3 is known as the pseudochiral carbon or pseudochirogenic or pseudochirotropic carbon. So we can say we can define the carbon atom which is chiral just because of difference in configuration, right? One is R and one is S, suppose between two identical group. Okay, both group are identical, that is both are constitutionally same. Attached to carbon is known as the pseudochiral carbon or pseudochirogenic or pseudochirotropic carbon. I hope you understand, right? Now I will draw number of stereoisomer over here. So in previous lecture I have explained you this molecule in which total number of stereoisomer, optically active stereoisomer and optically inactive stereoisomer. So this is the symmetrically substituted molecule with odd number of stereoisomer. So total stereoisomer is 2 raised to n minus 1. Optically inactive, optically 2 raised to n minus 1. Optically inactive is equal to 2 raised to n minus 1 divided by 2, and this is the total minus inactive. So here n is equal to 3. So here we can write 2 raised to 3 minus 1, that is total 2 raised to 2, that is 4 stereoisomer are present, in which 2 raised to 3 minus 1 divided by 2, that is 2 raised to 2 by 2, that is that in which 2 are optically active and 2 are optically inactive stereoisomer, right? Now I will give example. So firstly we will talk about the pseudochiral carbon, right? So suppose OH, OH and OH, right? Suppose I assign the configuration at carbon number 2, 3 and 4. Now for carbon number 2 you can say 1 is given to OH, so 1 is given to this one, right? Another one 2 is given COH group, and this is the third number. So and this is the fourth number. So 1 2 2 2 3, that is anti-clockwise. So 2R, but 4 is present over here, so 2R become 2S. So it is 2S configuration, right? Okay. Now suppose I think about this carbon number 4. 1, this is the 2 and this is the 3. So 1 2 2 2 3, that is clockwise, sorry, here in clockwise. So 4 are present, so 4 are 2, 4S. Sorry, here anti-clockwise, so 2S become 2R, it's my mistake. So we can say 2R and 4S present over here, right? Now we know that if this has R configuration and this has S configuration, then we can find out the R or S for carbon number 3, because according to the CIP rule R has more priority than S. So this both functional group are constitutionally same, but configurationally they both are different, right? So center carbon, this carbon is known as the pseudochiral carbon, right, due to the change in configuration. So if I find the configuration at 3 number carbon, so OH has given 1 number, then R has 1 priority, so 2, this is the 3, right? So 1 2 2 2 3, that is anti-clockwise, so S S2 R, so 3 S2 3 R. So for pseudochiral carbon we are writing in small letter 3R, right? So small r and small s is used to describe pseudo symmetry, right? So same to same, suppose I think about the another molecule. Suppose OH and OH, right? Now for pseudochiral carbon there will be plane of symmetry also present, right? Here plane of symmetry is also present. So if I find the configuration, then this is 2R and this is 4S, right? And for 3 number carbon, it is pseudochiral carbon, it is also pseudochiral carbon, right? So 2R 4S, right? If I find the configuration at 3 number carbon, then it is S configuration, so 3S, small s is used, right? Small s is used. So small r and small s is used to describe pseudo symmetry, and the pseudochirogenic center is possible in symmetrically substituted molecule with odd number of chirogenic center, right? So this is the symmetrically substituted molecule with odd number of chirogenic center. So these both are meso compound. Here we can say that is optically inactive, in which central third carbon is pseudochiral carbon due to the change in electronic configuration. Okay, so this we can explain. Thank you very much.